we have a transformation right here. This is the isopropyl group, and we have isopropyl benzene, of course, and we need to convert it into this compound. So we have a sulfonic acid down here, and we have a carboxylic acid up here. Now we do know things that we need to remember. So we are going to remember, before we do this, we're going to remember that we can oxidize the benzylic carbon. So let's put a CH3 here. We can oxidize it to the carboxylic acid by using potassium permanganate under basic conditions. So we can convert the benzylic carbon to a carboxylic acid as long as the benzylic carbon has at the very least one hydrogen. And that's exactly what I have right there. I have only one hydrogen. So what we need to do is that we need to take this isopropyl benzene, and we're not going to do this oxidation first. And I tell you why we're not going to do that oxidation first. Because this isopropyl is an orthopara director, and I want the sulfonic acid to go to the para position. So I'm going to use the orthopara directing abilities of the isopropyl benzene, and I'm going to use it to put the sulfonic acid on the para position. Now I need sulfuric acid, and I need sulfur trioxide. Sulfur trioxide is the actual electrophile, and since they're both bulky groups, the isopropyl and the sulfonic acid are going to end up para to each other. So this is going to be the major product of the reaction. And now I can do the reaction with potassium permanganate. The potassium permanganate is not going to do anything to the sulfonic acid we just put in there, but it's going to take the benzylic carbon of the isopropyl and oxidize it to the carboxylic acid. And this is the product that we wanted to get.